Alright, so this is exponent rules. I'm not going to do a video on exponential functions because I'll just teach that when you get back there. But for right now, I'm just going to explain exponential rules. Okay, so that way you can do that worksheet too. Alright, so there's five or six big rules. Okay, so I'm going to show them to you a little bit. Okay, so first one is, what is an exponent? Okay, so b to the x power. So if I said b to the x power, you'd look at me like I'm crazy. So I'm going to say something like this. So 4 to the 5th power. What does this actually mean? Well, this means this. You're taking 4 and you're multiplying by itself 5 times. So if I showed you it in an expanded form, I'd show it look like this. It'd be 4 times 4 times 4 times 4 times 4. Okay, that's what an exponent means. It means take this, multiply itself 4 times, and this is what it look like in real life. So, when I say b to the x, what I mean is this is the base and this is the exponent. Okay, so our first rule is known as the addition rule. What this means is if you have an exponent, or if you have a base with an exponent and you have a base with another exponent, okay, so if you have b to the x times b to the y, so if they have the same base and they're multiplying, what you do is you actually add the exponents. Let me show you why that works. So let's say we have 4 to the 5th times 4 to the 7th. Okay. If we follow these rules, that means that we're going to have base 4, and we're going to take 5, we're going to add 7. So it's going to be 5 plus 7. Okay. So that means that this is actually 4 to the 12th power. Let me show you why this works. Well, if I expand out both of these things, the 4 to the 5th and the 4 to the 7th, I'm going to have 4 times 4 times 4 times 4. Okay, so there's 4 to the 5th. Multiplied by 4 times 4 times 4 times 4 times 4 times 4 times 4. And this is 4 to the 7th. Okay? Now, if we actually add this up, this is actually 4 times itself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is technically 4 to the 12th power. This is why this works. Okay? So, that's an explanation of the first one. Now, let's go with subtraction. So if you have b to the x divided by b to the y, it's actually b to the x minus y. So let's go again with the whole exponent thing. So let's say we have 5 to the 3rd power divided by, actually let's go 5 to the 6th power divided by 5 to the 3rd power. Okay, so let me show you why this works. If I was going to write this out, it'd be 5, the top one would be 5 times 5 times 5 times 5 times 5 times 5. Okay, so you have 5 6 times. So this is 5 to the 6th power divided by 5 to the 3rd power, 5 times 5 times 5. Okay. Well, let me show you what happens. Technically, we can cross things out. So 5 divided by 5, well, that's going to be 1, so that crosses out. 5 divided by 5, that's going to be 1. 5 divided by 5, that's going to be 1. We have 3 5s left. 5 times 5 times 5, which equals 5 to the 3rd power. But if we use our rule, 5 to the 6th divided by 5 to the 3rd equals 5 to the 6th minus 3, or 5 to the 3rd power. Notice how that rule works out as well. Alright, then you've got any exponent to the 0 power. Alright, our next rule, any exponent to the 0 power, anything to the 0 power equals 1. Anything to the 0 power equals 1. That means if I had 8 times 5 times 4 third power, second power, first power times 70 or 67 to the 67th power, so on and so forth. If this is all raised to the 0 power, technically this all still equals 1. That's the beauty of that. So anything to the 0 power is 1. Then you've got exponents raised to another exponent. So if you have b to the x raised to the y power, this is what it means. You're going to take, it's going to equal b times x to the y power. Let me show you why this works. So let's say we had 4 to the 5th power raised to the 7th power. What that's telling us to do is take 5 times 7. Okay, so that's going to end up being 5 times 7, which equals 4 to the 35th power. Why this works out is if you think of it like this. If this tells us how many times we're going to take this and multiply it against itself, then we're going to do this 7 times. So it's technically 4 to the 5th power times 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 4 to the 5th power. Okay, and if I expand this out, alright, it'll be 4 times itself 35 times. I don't know if you like expanding it out, but you get the idea. So if you take this number, if you have a number on the outside, an exponent on the inside, you raise the whole thing to the 7th power. Okay, and finally is b to the negative x. Okay, so if you have b to the negative x, this is what happens. If you have b to the negative x and it doesn't have like any, it's either on the top of a fraction or it doesn't have a fraction at all, you put it on the bottom of the fraction. Over here, if it's already on the bottom, then it goes to the top. So let me give you an example. So if I had 4 to the 5th power divided by 4 to the negative 3rd power. Okay, this is on the bottom and it has a negative exponent. So this is what happens. You bring it up. Okay. So instead of 4 to the negative 3rd power, you get 4 to the 5th times 4 to the 3rd. Okay, so this went to the top and became positive. So let's say we had 4 to the negative 7th power. Okay, that's the same thing as saying over, I don't know, 4 to the 3rd power. So you take this, you bring it down. So this will become 1 over 4 to the 3rd power. And this went down. So this is 4 to the 7th power. And then you do the whole combining like terms, so on and so forth. Now, with all those rules in mind, let me give you some examples. So first example, let's say I had a to the 2nd, b to the 3rd, times a to the 4th, b to the 7th. Okay, so you have these two things multiplying to each other. Well, so they're multiplying, that means we're going to be adding the exponents. But we only can add things that are like. So these two are alike, and these two are alike. Same bases. A, so this is going to be a to the 2 plus 4. This will be b to the 3 plus 7. Okay, so this is actually a to the 6th, b to the 10th. These rules are simple. Okay, let's say I had, I don't know, x to the 3rd, y to the 2nd, z to the 5th, over x to the 2nd, y to the 5th, z to the 2nd. Okay. Now, we can do one of two ways here. I'm going to show you both ways. So first thing is we can actually expand this entire thing out, because when it comes to division, it gets really hard for students to understand this. But I'm gonna expand this out. So this is for x to the third power. That means we're gonna have x times x times x. Y to the second means we're gonna multiply by y twice, and then z to the fifth we're gonna multiply by 5 times. Okay, let's do the bottom one. Be x to the second times y to the fifth times z to the second. Okay, so let's cancel out things that are alike. So I can cancel out this. It's one side I can cancel out. I can cancel out another side. Well, the x is left over. Okay, so I can't do anything else with that x's. Now with the y's. Let's cross out one set of y's, two sets of y's, and that's all the y's I can cross out. Finally, the z's, common, common, and then this is what's left over. On top, we have 1x, x to the first power, and we have z, we have 3 z's, so z to the third power. On the bottom, we have y to the third power. So that's the most basic form, but the proper way to do this is actually like this. Since we have x to the third, and we're being divided by x to the second, we'd take 3 minus 2. Y would be 2 minus 5. And z would be 5 minus 2. When we did that, we'd get x to the first, y to the negative third, z to the third. And since y is a negative third, we actually have to go back to this whole thing. When we have negative exponents, we either got to bring them down if they're on top, or if they're already on the bottom, they go back up. But in this case, the y is on top, so we have to get the x1, z3, and the y has to go back on bottom because it's negative, so that we can make it positive, so it's got to be like that. So whichever way best suits you, do that one. This just takes longer, but this it seems to be more confusing for a lot of students. So if you really don't understand it, I would expand them all out, cross them out, and then put them down like that. Otherwise, you should do that. Okay, so let's say we had A to the third, B to the fourth, C to the sixth, all raised to the 0 power. Once again, anything raised to the 0 power equals 1. Now, this is not to be confused with something like this. If I had A cubed, B to the 0 power, C to the sixth, all that would happen is that the B would disappear, since B is the only one being raised to the 0 power, so this would just end up being A cubed, C to the sixth. But since this whole thing's being raised to the 0 power, that's why that whole thing equals 1. Okay, technically this B would turn into a 1, and anything times 1 is itself, so it'd be A cubed times 1 times C to the sixth, or just A cubed C to the sixth. That's the whole idea. Okay, so the next one, let's do some. So we did division. Let's do A cubed, B to the fourth, C to the seventh, all raised to the 7th power. Alright. So what we actually had to do with this is essentially it's distributing to since we're multiplication is when you raise a power to a power, you'd multiply the 3 exponents on the inside. So this actually be 7 times 3, which would be a to the 21st power, b to the 28th power, and c to the 49th power. Yeah. It's going to get a lot trickier, especially when you get something like this. A to the negative second, b to the third, c to the, I don't know, let's go with fourth, all raised to the negative second power. So when you have something like that, once again, you still distribute to all the little things on the inside. So this would be negative 2 times negative 2, which would be a to the fourth power. This would be 3 times the negative 2, which would be b to the negative 6th power, and c to the negative 8th power. And since we can't have negative exponents, these are on top, they'd have to go to the bottom. And it would look something like this. If you need more help with this, I'd continue searching on YouTube for exponential rules, exponent rules, and it should give you a little bit broader of an explanation if you didn't understand mine. Alright, thank you.